This video is going to show you the answers to some of the problems on the exercise on Khan Academy with the title Radians and Arc Length. And this practice was assigned to you on week 3 of distance learning. Let's get started. First question is asking, what is the length of arc S shown below? Now over here on the right side, I've written down the formula of how you can get the arc length. Arc length is simply equal to the radius times theta, and theta is the angle measure. So all we have to do is plug in the given information to our formula. So in order for us to find arc length S, we're going to have S being equal to the radius, which in this case is 8. Remember, the radius is the distance between the center to the circle. So that is 8 times theta, which is going to be the angle measure, which is 3. Multiplying those two together, 8 times 3 will simply give us 24. So arc length is 24 units. Let's look at this next question. Write a formula for arc length S in terms of R. Okay, so what the first thing I'm going to do again is I'm going to put, actually let's just abbreviate. Arc length will be AL. Arc length is equal to radius times theta. So radius, good enough. Radius times theta, which again is the angle measure. All right, so if we have the radius here is R. So if we have the radius is R, and we have theta as 1.2, multiplying those two together is what's going to give us our arc length. Now in this situation, we're not even being asked to determine the arc length itself. We're just being asked to write a formula for it. Now conventionally, when you're multiplying a variable to a number, the number comes first. So I'm just going to clean this up a little bit and say that arc length S, which is the letter we're using here, is going to be 1.2 R. Okay? Now again, we were being asked for a formula. We were not asked to find what S equals. So I'm going to put 1.2 R. All right, let's do another question. What is the measure of theta in radians? Enter an exact expression. That means when we're working with exact expressions, we're going to keep pi in our final answer. This is a little bit different because we are given the arc length, we are given the radius, but we are not given the angle measure. So remember, arc length is equal to, I'm just going to abbreviate, radius times theta, which is what we're looking for. We are given the arc length. The arc length is given to us as 8 pi. And that is equal to, we are given the radius. The radius in this case is 8. And theta is what we are looking for, so I'm still multiplying this by theta. Now if I want theta by itself, that means I have to do the opposite operation that I see here. Currently theta is being multiplied to 8, so I'm going to do the opposite, which is division. I'm going to divide both sides by 8. Well, 8 and 8, 8 divided by 8 becomes 1, so this simply just becomes theta. It's 1 theta. And 8 divided by 8 also appears on the left side of the equal sign. This also equals 1, which will give us 1 pi. So theta is equal to pi. So pi will be our answer. This will be the last question we're going to do for this exercise. It states, an arc subtends a central angle measuring 2 pi over 3 radians. What fraction of the circumference is this arc? Now, the first thing I wanted to talk about was that a fraction is just anything where the part is over the whole. We're just looking how many parts out of the whole thing are we looking for. We're going to come back to this concept in a second. First thing we have to do is we have to figure out the arc length. All right, let's figure out how long this whole thing is. Now remember, arc length is just, let's call this S. Arc length is just radius times theta. Well, the radius is given to us as r, and theta is given to us as 2 pi over 3. Because I see a fraction here, what I'm going to do is I'm also going to make r a fraction, so I'm going to have r over 1, so that I can easily more identify what the numerator and the denominator are. So let's go ahead and multiply across. R times 2 pi is going to be 2 pi r. And in the denominator, 1 times 3 is going to be 3. That means that the arc length S is simply 2 pi r over 3. Now the question is, what fraction of this whole circle in green is that blue arc? In other words, out of the whole circle, what part of it are we only talking about? Well, for us to be able to do that, first is we have to know the arc length of the whole circle. Well, the arc length of the whole circle is simply its circumference. And to find the circumference of any circle, the formula is 2 pi r. In this situation, we're not even given anything else. We're not given the measure of the radius. So the circumference in green will simply be 2 pi r. Let's make that a little bit better. 2 pi r. Okay, that's a little bit neater. Okay, now let's actually answer the question. The question is, what part of the whole green circle is this blue circle, blue arc? Now remember earlier I was talking about fractions, where this is always a scenario. We're always just looking for the part over the whole. Well, in this case, the part is 2 pi r over 3. So I'm going to put that in my numerator because that is this section. That is the part. Now the whole is 2 pi r, so that's what I'm going to put in my denominator. That is the circumference of the whole circle. So now that we've got the part over the whole, let's just go ahead and simplify. Well, what I have here currently is that I have a fraction in the numerator. And an easy way to simplify that is to make your denominator a fraction also, and multiply your numerator to the reciprocal of your denominator. It'll look like this. I'm going to write the numerator exactly as it is, 2 pi r over 3. And I'm going to multiply that to the reciprocal. So I am going to flip the numerator and the denominator. I'm going to have 1 over 2 pi r. Okay. Now what do I see here? I see that the numerator of the first fraction and the denominator of the second fraction are exactly the same. That means that those will cancel out to become 1, and we can get rid of it. And we are going to be left with 1 over 3. Now this means that out of the whole circle, this blue section is 1/3 of it. So 1 over 3.